Hey everybody, Mr. Midas is here again, and this time this is 6-2b, inverse trig functions, and now we're going to be integrating. So now we just did derivatives, now we're doing integration. So think of this as just going backwards. So you're just looking for something that looks like it was the derivative of an inverse trig function. And the other important thing here is that you don't have to find the integral that's going to end up being an arc cosine, because arc cosine, remember, was just the negative of arc sine. So really that negative comes out of the integral anyway, and you end up with an arc sine. So you don't have to remember that one. You don't have to memorize that. All you got to do is memorize arc sine and arc tangent. Now, here are the two, again, with the flies. Here are the two formulas that you need to, or derivatives that you need to memorize. And these are also include the chain rule or the reverse chain rule for integration in them. U is going to be whatever's in that square, and A is any whole number that's in there. So we normally want to change that in there so we can see that. Okay, so for number 11 here, we're going to just, you know what, this one is just like, if you notice that one, 1 over 4 minus x squared, there is a fly right here bugging me, guys. That's just like the previous video example here. Number 10, right? 1 over square root of 4 minus x squared. And that one was arc, I believe, arc sine of x over 2. But let's just take a look at what you would do, so that way you can kind of understand what we would do anyway if we didn't know that. Notice that 4 is really 2 squared, right? 2 squared minus x squared. So now we've got it in the form of this right here. So I'm just going to rewrite this now as arc sine of u is x, right? U is equal to x in this case. What is A? A is 2, because 2 is squared, plus c. And that's it. All right. All right, let's look at number 12. Now notice there's no square root. So automatically we're like, okay, well, this is not going to be an arc sine. And it's x squared plus another number. So we're thinking, oh, an x squared on the bottom, nothing on the top. This must be an arc tangent. So what we're going to do here is we need to first figure out what u is going to be, because remember, see, we have u's and a's here. So whatever is squared, we want to put that together. And notice here that we're going to have 2x squared. Okay, so in this case, u is 2x. So what's u prime is going to be 2. Remember that u prime goes on top. So we need a 2 up here. If we need a 2 up there, we need a 1/2 out here. Okay, what is a? A is 5, because this is 5 squared. So we really got something that looks like 1/2 2dx over 2x squared plus 5 squared. Now we can put that in there. We know it's 1/2 arc tangent of u over a. U was 2x, a was 5, plus c. That's our answer. Okay, all right, let's look at the next one. You kind of get the hang of these once you start looking. Okay, you're looking for these things squared, right? All right, so now this one's a little bit different. But you notice that you should notice, okay, wait a minute, this is going to be an inverse tangent, because I got an x squared there plus thing, and there's no square root. So what is u? U is going to be 2x, right? Because this is going to be 2x squared. Well, if this is 2x squared, what's a got to be? A's got to be the square root of 3, so that I get the square root of 3 squared. All right, well, u prime is 2. Well, we got an 8 there. So I don't really want an 8. I want it to be 2. So I really want this to be 2. So what needs to go out here? 4. Now you're going to go, wait a minute. 4. Mr. Midas, why does 4 go out there? Because 4 times 2 is 8. And I already have an 8 there. So I don't have to put more stuff into my problem. Okay? I just needed to get the inside to look what it needs to look like for me to take the antiderivative. Okay, so I'm going to have 4 inverse tangent, so arctan, of u over a plus c. Bam. All right. Did I miss something here? Uh-oh, I missed 1 over a. 1 over a. I missed 1 over a. So I also missed it in 12. So I need to put 1/5 over here. Okay, let's not forget that over here. 1 over a. So let's go ahead and put that 4 over root 3. Okay, so don't forget that 1 over a. I almost, memorize those things too. I almost forgot. Okay, now you look at this and go, hey, there's an x squared on the bottom. It must be an inverse tangent. But wait, there's an x in the numerator. So we got to be careful, because when there's an x in the numerator and an x squared in the denominator, this is probably going to be a logarithm. Because remember, what's the derivative? What's the derivative of 4x? That's 8x. Right? The derivative of 4x squared is 8x, which is what we have here. That's actually a hook. So really, what we got here, actually not 4x squared, 3 plus 4x squared is 8x. Okay, so that's actually a hook. What we got here is we actually have a reverse chain rule. So we actually have ln of 3 plus 4x squared plus c. All right, this is not an inverse tangent. So we got to be careful when we look at that. How do we know it's an inverse tangent? Is because there won't be an x on the numerator. It'll just be an x squared in the denominator. All right, let's take a look at this one. Now we have an x squared in the numerator and an x squared in the denominator. What do we do if the powers are, the degrees are the same? We're going to have to use long division. All right, so we're going to go and use long division here. That's going to be 2, and that's going to give me 8x squared plus 6. And subtract, bam. And I'm going to get 2. Oh my God, this fly is making me very upset, guys. 6 over 3 plus 4x squared dx. Okay, now notice that we do not have an x in the numerator, but we do have an x squared in the denominator. So yes, we are in fact going to need to use an arctangent. So I'm just going to split this guy up here. Okay, I'm going to split this guy up to integral of 2 dx minus the integral of 6 over 3 plus 4x squared dx. And we know that the integral of 2 is going to be 2x. And we actually did something similar to this up here for number 13, right? So we're actually going to, let's see, we're going to put the 2 here and a 3 here because we needed a 2. We already know here that a is root 3 and that u was 2x. So we're going to have 3 from here times 1 over a, don't want to forget that again, arctan of u over a plus c. All right, there's our answer for that one. All right, let's take a look at the last one here. I think the bell's going to ring while I do this, just so you guys know that, because I'm right at the end of the day here. Okay, now you're looking at this and going, okay, I think Mr. Rice has said that there was an x in, okay, wait a minute, let's see. Let me go back up here, look at the thing. Is there an x in the top? Well, there's a u prime. So there shouldn't really be an x up there for me to do an arc sign. So what do I do now? Do I use u substitution? Well, if I use u substitution, that's going to give me a 2x. That plus 4 is making things difficult for me. So whenever I see a plus here, but I have an entire thing on the bottom, I'm always going to try to split that up. So let's go and split that up. X over root 4 minus x squared plus 4 over root 4 minus x squared dx. Okay, now that I split it up, now it should make a little bit more sense here. This one is not a inverse trig because I have an x in the top, and I know what's the derivative of 4 minus x squared. The derivative of 4 minus x squared is negative 2x, right? So negative 2x, I'm going to go ahead and put in a negative 2 here and a negative 1/2 out here because I have an inverse chain rule. This one, however, that one is an arc sine. This one's an arc sine, and what I'm going to do is I'm going to go ahead and I'm going to move this 4. I'm going to move this 4 in front. Okay, and this one, a is going to be 2, and u is going to be x, right? It's a squared, 2 squared, x squared. All right, okay, so now what I'm going to do, I'm going to take the antiderivative of the first one. This first one, remember, we noticed was a reverse chain rule. I'm going to rewrite this. Let's just rewrite it one more time. See what I'm doing. Okay, 4 minus x squared to the negative 1/2. Square root of 4 minus x squared dx. And we already know that this here is true. Okay, so we got negative 1/2. This is our hook, goes away. We're using an inverse, we're using a reverse chain rule. So we've got 4 minus x squared to the positive 1/2 divided by 1/2. We're using the power rule. Plus 4 times the arc sine of u over a plus c. All right, 1/2s cancel out, and look, there's the bell. And guess what? That was my last problem. So saved by the bell. Okay, guys, that's integration of inverse trig functions. Talk to you guys later. Bye.